Okay. And yeah, I guess I'll start with this list that I made up. In terms of, these are topics that are on both the MyLab midterm and the at-home or the part 1 written midterm. So things we're going to talk about today are qualitative versus quantitative. Qualitative comes from quality or trait. Those are categorical. And quantitative, that comes from the word quantity. So we're talking about numerical data. Oops. Write that down. So those again are categories and numerical data. The only thing to be careful of are the ones where they look like numbers, but they're really categories and hiding. So like if hotels or a hotel chain rates their properties as 1, 2, or 3 star, they could also call them luxury, standard, or economy. So sometimes the numbers are really just categories and hiding. So
okay.
you want to make sure that they're numbers that you can do arithmetic with too. So like a 3-star hotel, how much better is that than a 2-star hotel? Well, 3 minus 2 is 1, but that doesn't mean anything. So I'm not sure that there are any of those in my math lab, but you do want to be careful with those. The second major topic is discrete versus continuous. Discrete in this course, we're pretty much talking about whole numbers, things you can count. Continuous, decimals are okay. And it really means there are no gaps between the values, but decimals are really the key. If a decimal makes sense, then it's continuous. The one you want to watch out for there are ones like age, because when somebody asks for a person's age, they're always going to say a whole number, but it's a measurement of time. It's not really that exact whole number. So like if you say, I'm 25, you're really 25.327 years old at that instant, and that's constantly changing. So it's not really, that's continuous, not discrete. Let me see if I can switch out here. Oh, I don't have any of those on the practice one. I've got another one. Yeah. All right, so let's see, is that showing? That's not showing on my screen. Is that showing on yours?
No, I just see an eye.
Let's see. Okay, that's a little better, but that's kind of small. Does it show up as just part of the screen for yours?
I see chapter 1. Yeah, I see it's small though. Yeah, it is small.
All right, let's try.
Oh, wow.
At least zoom in. It's not showing the
yeah.
full screen. I'm not sure what. Oh, wait, maybe if I do. Nope, that didn't do it.
Oh, yeah, it did. It did.
Oh, it did?
Uh-huh.
Oh, there it is. Yeah. Oh, yeah. Thank you. Okay. Just working out some of the technology. This is a new program I'm using called Reflector, and it shoots things from my iPad that I can write on to the screen, which is pretty good.
Oh, I got an iPad. SJVC gave it to me. I'm supposed to start teaching off of that too. And I'm like, I don't even know how to use an iPad, but okay.
Yeah. And I don't know if they gave you the Apple Pencil, but they're really good if you.
I need to get that. They didn't. I need to purchase that on my own, but I am. My coworker told me to. Well, it's my husband's cousin. That's my coworker.
Yeah, the iPads are really nice, but like the pencil is if you're teaching, I think the pencil is the big difference.
Okay,
easier for marking stuff up.
Yes.
Right, so I talked about the difference between qualitative and quantitative, but I wanted to focus on these two let me start writing. These two right here. Which of these are qualitative and which are quantitative? The amount of time playing video games last week and the last video game you played. So amount of time, we're talking about a numerical value, that's quantitative.
Okay.
But the last video game you played, that would be a name of a game, that's categorical.
Yeah,
so that's qualitative.
Okay.
And so in my lab, there are a handful of questions that are pulled together. Each time you take the test, you'll get one of them. And so it'll change from problem to problem or attempt to attempt. but there's one of those that are on there. The next thing that I mentioned was discrete versus continuous.
I got
And again,
those.
discrete, I talked about the idea of whole numbers only, things you count, versus continuous, things that you measure, decimals are okay. And so the problem I want to look at is this one here. Identify the following as discrete or continuous: the distance that you live from COS and the number of classes you're taking this semester.
So the distance would be the continuous.
Right.
And the, okay, discrete would be the number of classes, because that's like I'm taking 3 classes.
Right. So you only take a whole number of classes. Those are things you can count. But the distance that you live is a measurement, a physical distance. That's always going to be continuous. Let me switch back. The next thing, the next topic I want to talk about is level of measurement, where we decide whether a variable is nominal, ordinal, interval, or ratio. And the first thing in telling those apart, nominal and ordinal, those are categorical or qualitative. Interval and ratio, those are numerical or quantitative. So when you're trying to figure out what level of measurement you're dealing with, the first question is, do I have categorical data or numerical data? If you know it's categorical, then you're working with the first two. If you know it's numerical, you know you're working with the last two. Also, these are in the order from weakest to strongest, the things you can do the least with to the things you can do the most with. And if you look at the first letters, that's the way I remember them, N-O-I-R. N-O-I-R is a French word, noir, but that helps me keep them in order from weakest to strongest. Now, if you have categorical data and you want to know the difference between nominal and ordinal data can be put in order from low to high, from worst to best, but nominal data cannot. Nominal comes from, there's a word nombre, well, it's in Spanish and Italian. Nombre means name, nominal means name only. And ordinal, you can see order right in there.
Got it.
So if there are categories, can I put them in order? No is nominal, yes is ordinal. If they're numerical, the real key distinction between these two is that ratio has a 0 starting point, meaning those values can't go below 0. So what you're really trying to think about are whether negative numbers are okay or not. If negatives are okay, that's interval level data. And if you can't get a negative number, then that's ratio. One thing that's a little tricky there is, say we were talking about Celsius temperatures of spring break destinations. Those numbers, when we record them, are essentially, those are going to be positive numbers. But because Celsius temperatures can be negative, that makes them interval. There aren't a lot of numerical data that can be considered interval. You have to think about things that can drop into negatives like elevation below sea level or profit and loss. But there aren't a lot that we deal with that would be interval. I do have a couple on here.
Great. Be quiet. My dogs.
Right here. So correct level of measurement, letter grades on an exam. Letter grades, is that categorical or numerical? If you think about the letters that you could get on an exam, those are categories, right?
The
Not
letters.
scores.
Oh, okay, right. Letters.
And we put those in order from worst to best.
Yes.
Yeah, so that would be ordinal.
Okay.
Oops.
Oh, so it's a qualitative ordinal. Okay, so that's ordinal.
Weights of butternut squash. Weights, would that be categories or numerical?
Numerical.
Numerical. And then the question is, can they be negative?
No.
No, right? It can't weigh less than 0. So that would be ratio.
Okay.
Colors of M&M candies. Categories or numbers?
Well, it depends. Are you counting the colors or?
Yeah, so it's not the, we count all kinds of data, but it's what the data values would be. So if I got a bag of M&Ms and I pulled one out, the first thing I would write down is brown or yellow or blue, whatever it may be.
A category.
So those are categories. And then, is there a worst category? Is there a best category? And that answer would be no. So these would be nominal because they can't be put in order from worst to best. Hey, Toby, welcome in. I'm just working through some of the main topics. The parts that you missed before you got here, I will, I'm recording the session and I'll post it if you want to go back and take a look at what we've talked about so far is quantitative versus qualitative and discrete versus continuous. And we're in the middle of levels of data. The last one on there, temperatures of US cities, categories or numbers.
That's a number and it's like interval because it can be negative.
Right. So because that one can drop below 0, that's going to be interval instead of ratio.
Okay.
There's really no difference between those two in terms of what we can do, ratio and interval, other than you can't make a ratio saying this is twice as much as that if they can be negative. So like today it's going to be 100 here in the valley and someplace in the Northeast it's going to be 50. We can't say that it's twice as hot here as it is there because the temperatures can be negative. You can't make those sort of ratio arguments. That's the only difference. You can still compute mean, median, all that other stuff. You just can't make those ratio statements. That's the only difference. All right. I do want to, let me just move to the next page. I don't have any anything prepared for observational studies versus designed experiments, but you've got to be able to tell the difference between those two. There's one problem that'll ask you, is this an example of this kind of study or a designed experiment? And the difference with the two is that in a designed experiment, from the beginning, you're making controls for what you're trying to measure. So you're affecting the way the data is collected. In an observational study, whatever happens, happens and you collect the data. So an example would be like if we wanted to do a study about whether students eat more in terms of calories the week before an exam. If we had students just writing down what they ate all semester, and then we took the week before the exam and compared it to other weeks, that would be an observational study. But a designed experiment would be something like having some students take an exam, choosing some students to take an exam and some students not to take an exam, and comparing those two groups. We've decided who's going to get which treatment. That's a designed experiment. So what you're really looking for is some suggestion that the researcher is controlling the setup of the experiment.
Like a placebo, like in the medical.
Like a placebo, like who gets the medication, who gets the placebo. That's a designed experiment.
Okay. That is designed because okay, got it.
Right, because we're controlling who gets which one from the start. So when you're reading through those, that's really where you want to be careful. Look for that idea. Okay, so sampling methods are next, and there are two types of questions on sampling on this exam. One is for you to identify which sampling technique was used. And then there's a second one that asks you to do some work with systematic sampling. And so I will go through some of those. I've got the 5 methods listed there. Convenience is really just where you gather data in a really easy way, where maybe you're in a public place and you're just asking people going by, or you're getting somebody else's data that they already collected. Random, a lot of them will say random in them, but they're not all random sampling. Random sampling means that every person in the population is numbered. Those numbers are put in a hat or in a computer system, and you pick them out by chance. Cluster has to do with dividing the population into locations, and then you select certain locations and survey everybody in those locations.
Okay, I get it.
So cluster sampling used to be really popular before, before say everybody had a telephone, because like if you wanted to get an idea for how people in New York City felt and you couldn't contact them by phone, what you could do is go out to different city blocks and ask everybody that lived in that block, and you'll pick a half dozen blocks at random. That's cluster sampling. We don't do a lot of that anymore, but it still does show up. Like even at school, if we wanted to know how students felt about a particular new program, we could just pick a dozen classrooms and go talk to people in those classrooms. That's cluster sampling.
Okay.
Systematic is the one where you pick a starting point and how big your steps are going to be. So the population is numbered from 1 to n, and maybe you start with person 17 and you take every 30th person from there. There's a system to who gets picked. Stratified is probably not going to show up in any problems because it takes a lot of space to write what happened, but we break the population into groups and subgroups of those subgroups, and then we pick people from each of the little subgroups. So like, for instance, if we were doing an election poll, we might break voters into male and female or other. We could break them down further by which party they belong to. We could break that down further by their income, their race, their ages, and we end up with all these little pieces of the puzzle, and then we select from each piece. That's stratified. We break it into strata or layers is the idea.
Oh, just like I'm learning in anatomy, okay.
Yeah, it's the same word,
stratified
right?
cells.
Yeah. But in this class, you probably won't see it because for me to type all that out, by just reading how much is there, you're going to know it's stratified anyway. So you probably won't see that one. I do have a few of those prepared. Yeah, so sampling techniques. The first one, to determine the average household income for COS students, a researcher numbers the students from 1 to 12,384. She begins with student 86 and includes every 407th student from there. That is systematic. There's a starting point. There's a step size. So we started at 86 and then we add 407 to that and 407 to that. And that tells us which one to get. So that is systematic. I crossed off B and D to remind myself not to do those because you're going to see those on the actual exam. So I'll leave that to you at that point. For C, to determine the mean age of COS students, a researcher numbers the students again. She then uses StatCrunch to generate a list of 100 random numbers and uses them to determine which students will be sampled. That is actually random sampling. They're numbered and the numbers are being selected by the computer. E is the systematic sampling problem. And I crossed this one out because it's pretty similar to what's on the exam. But I've got another one on the practice exam that I thought we could walk through instead. Yeah, it's right here, number 2. An online store has a database of customers numbered accordingly. The store decides to send surveys to a sample of 100 customers using systematic sampling. The first thing I want is the step size. Right on that. The step size, remember, is the population size divided by the sample size. And we round that down. So in this case, 9,458 divided by the sample size of 100. 9,458, that's how big the population is. 100 is the sample size that we desire.
Okay.
When I divide that, no calculator needed, right? 94.58. But we always round that down. If we don't round it down, say we pick 95 instead, which is closer to, if we keep counting by 95, we might go past the end of the list, which in itself is not a bad thing because if you go past, you can always just loop around to the beginning again. But we pick 94 so that we don't have to mess around with that.
So that's the step size.
That's the step size.
That's okay. That's how you figure out the step size.
Now, you're being given the starting value of 50, and we want to know some different numbers in the sample. So the first is going to be that starting number. That's going to be 50. To get the next person, you have to go up by that step of 94. 50 plus 94 is 144. Another 94 to the next one is 238. Now, if I want to get to 800, I could keep adding 94 and 94, but this session's only 30 minutes. So the better way to do that one is the last number is always the starting point plus one less than the sample size times the step size. So if you think about it, to get the second number, I took 1 step. To get the third number, I took 2 steps. To get the 800th number, I have to take 799 steps. So that's what's happening there. So for this problem, that would be 50 plus 799 times 94. I should have brought my calculator for that one. Oh, and I don't know why I used 800. This is going to get a little easier. I left that as 800th, but that should be 100th because that's what it's asking for.
Oh, 100?
Yeah. Why is that not showing? Oh. Sorry. Yeah, I got disconnected. So it should be the 100th. So I'm going to restart that as 50 plus 99 times 94.
Okay.
So I did that in my head before, and I was having trouble multiplying 799 by 94. I can do 99 times 94, though. This is 9306 plus 50. And that's 9,356. That would be the last person selected.
Do you do that 99 times 94 first?
Yeah.
Plus 50. Right.
Now, if you have a more modern graphing calculator and you type in 50 plus 99 times 94, it should do the order of operations correctly. But the safe way to do it is to do the multiplication first and then add the 50 after that.
Please excuse my dear Aunt Sally. I remember that. That's how I learned my order of operation.
I think that's how we all learn them. Let's see. So I got through systematic sampling. Oh, there it is. And I still have some chapter 2 stuff to do, but that's really what you are expected to be able to handle from chapter 1. Chapter 2, there's a question that asks you to make a pie chart. Now, when you do that on the part 1, you can either copy and paste that into a document from StatCrunch, or you can make it in StatCrunch and then roughly translate that onto your paper. It doesn't have to be perfect, but if one of the pieces is this, and you draw it like this, that's not good. If it's supposed to be this and you draw this or this, that's close enough. I should be able to hold your paper up next to my computer and say, oh yeah, that's the right graph. So again, it doesn't have to be perfect, just a rough sketch, but it should be close. Bar graph, both of the ones on the exam, you'll be making them from summary. So that's the way we're going to do them today. But it's possible that in the My Lab part, you might have to use data. And the difference is whether you have the categories and the numbers listed, or if you just have all the individual data in one column. If you have a count of how many of each variable shows up, that's summary. If you've got a column with the data, that's with data. Finally, there's one problem that involves taking a histogram and making a frequency distribution out of that. We'll walk through that. But there's also problems in My Lab that'll ask for something. They'll give you a frequency distribution and they'll ask you some things based on definitions, and we'll talk about that too. So I'm going to switch out to the yeah, the no, that's not that one. I want this one. So first, I'm going to jump down to part C. It says, use the given histogram to create a frequency distribution. You'll see one like that on the practice one and then also on the actual exam. I look across the bottom for the breakpoints for the classes. I see the first bar goes from 8 to 10, the second from 10 to 12, and so on.
Is that this one on the practice?
Yeah, those numbers will be a little different. I'm going to work through this one so that you can do that one on the practice on your own.
Okay.
But so on the one that I have on the screen, the classes go from 8 to 10, 10 to 12, 12 to 14, and all the way up to 20.
Okay. Okay,
And then
I see that.
The counts are given above the bars. So I can see, for instance, the first class has a frequency of 4. The second class has a frequency of 5, 19, 10, 1, and 1. Those are the class frequencies. Now, before I go on to part D and the relative frequency distribution, I did want to talk about these definitions that I wrote up near the top. So one of the questions is going to ask, how many classes are there? The classes are the groups that you have. And so here there are 6 classes to work with. The next thing they're going to ask are what are the lower limits and upper limits? And the lower limits are 8, 10, 12, 14, 16, 18, those first numbers in the class. The upper limits here are the second column, 10, 12, 14, and so on. The thing to remember is that the upper limit is not actually included in the class. So if we had a number that was 10, I'm supposed to put that in the second class, not the first class. When it says 8 to 10, what that means is 8 up to, but not including 10.
Okay.
Now, the class width is how far it is from one class to the next. So from 8 to 10, from 10 to 12, that's a distance of 2. So that would be the class width.
I have a question on those. We wouldn't put like 8 to 9 and then 10 to 11?
Yeah, so the
12 to
problem
13?
is this setup works better for all cases, because if you have data that can be decimals, you could go from 8 to 9.9, but what do you do with 9.93 or 9.97? And so we, as a practice, we let the upper limit be the lower limit of the next class.
Okay, so can you, I'm sorry, the lower and upper limit, can you, I didn't get that.
Yeah, so the lower limits are these numbers that are listed first, and that's the beginning of the class. The upper limits are the numbers that are listed second, and that's where the next class begins. That's where the current class ends.
Got it.
So yeah, if we knew these were whole numbers, we could say 8 to 9, 10 to 11, and so on. But I don't know what this data represents, and so I have to assume that decimals are possible, and that's why it's better to go 8 to 10, 10 to 12, and so on.
Okay, I got that.
For the relative frequencies, you have to know how many values there are total, and here there are 40. And the relative frequencies, you just have to divide each frequency by the total. So 4 divided by 40 is 0.10. 5 divided by 40 is 0.125, and so on. Now, technically, if you didn't want to do it this way, you could do an end around in StatCrunch. You could type in one column, instead of 8 to 10, 10 to 12, you could just type the letters A, B, C, D, E, F. And then you could type the frequencies next to them. And you could make a bar graph, but with relative frequency instead of frequency, and it'll compute them for you. The one on the practice and the one on the actual part 1 of the midterm, The divisions will be real easy. They'll terminate, so dividing them out won't be too bad, but you can do that one either way.
Okay.
So that's the problem that has to do with a histogram. And inside of my math lab, these are the questions that'll get asked to make sure you understand those definitions.
Okay.
The last two things I have are pie charts and bar graphs. And so I'm going to use the data that's at the bottom of that screen, except I'm just, for the sake of brevity, I'm just going to type letters there. Oh, maybe I'll type the actual thing. So let me switch out to the StatCrunch screen. So the 5 teams were Patriots, Raiders, 49ers, Cowboys, and other. And those frequencies were 80, 70, 50, 30, and 20. So the two graphs that you might have to compute here are the bar graph, the pie chart and the bar graph. The pie chart is under graph pie chart with summary. Categories were in that first one. The counts were in the second, and compute. And so there it is.
Oh,
Now,
I see.
Now all I have to do is do a rough sketch onto my paper of what I see. You should label the category and the percent with them.
Okay.
But if you're doing it electronically, you can copy this graph under options, copy, right click it, and then you can paste it into whatever document you want to paste it into. Either way, but by hand is definitely good enough.
Okay.
The other graph you might have to do is the bar graph or the bar plot, again with summary. Categories, the first group.
Oh, I see. It says create a bar and a pie chart.
Yeah, so in the in part 1, those are going to be separate problems. So you'll have 2 different sets of data, I think. One you'll make a pie chart, one you'll make a bar graph, if I remember right. So this is just a regular bar chart. And again, you can just rough sketch this back onto your paper. That'll be good enough. In the problem that we were just looking at though, if I wanted the relative frequencies, all I have to do is go to option edit and change the type to relative frequency. And then those numbers will show up at the top of the graph. So you can get them that way as well.
Off the bar graph.
All right, so those are the first 2 chapters. I think a good strategy would be to try the problems from chapters.
Can you show me the bar graph really quick, how you got there in StatCrunch real quick?
Yeah, so that's under graph, bar plot with summary. And then you pick, just like the pie chart, you pick the categories first, the count second, and then you decide whether you want frequency or relative frequency. All right, so I do think it's a good idea to look for the problems at the beginning of the practice midterm that are based on these problems. Try those, check your answers to the answer key. If you've got those right, then you can go on and do the ones on the part 1 of the midterm that go with that with some confidence. The other thing that you can do is you can open up part 2 of the midterm and go looking for those problems that relate to the chapters 1 and 2. They are in order, right? I inserted them in order. So you can go over those problems as well. When you start it, you have 12 hours to finish. But if you do chapters 1 and 2 and it takes you an hour and you just close it out, you'll still have 11 hours to come back and finish the rest.
Okay.
Like whether that's tomorrow or 2 days from now.
Okay.
So it pauses the time when you go out. The only thing I have to warn you about is just don't submit it. Because if you submit it, it grades it, and then that's 1 attempt that's gone. Just close the whole window. And it'll warn you, are you sure that you want to leave? And that's a definite yes. And then you can come back and restart it after.
Okay.
Okay. For those of you that are watching the recording afterwards, If you come up with any questions from chapters 1 and 2, you can send them to me during the day today and I'll put together a response to you. Or if you need to set up a Zoom session, we can do that as well. Tomorrow, I'm going to do chapters 3 and 4. That one's going to be at 10 o'clock instead of 9 o'clock. I had to arrange something to do it earlier today, but tomorrow I've got something early, so I had to move it back a little bit. So tomorrow will be at 10 a.m. instead. And then I'll do chapters 6 and 7 on Thursday. And then the rest of the time we'll just
Are you going to do that
questions.
one at 9 a.m.? Because I have my home inspection that day at 11, all the way in Kingsburg. So
yeah, I can go back to 9 on
Okay.
Thursday for sure.
Okay,
Yeah.
perfect. We got to get
Yeah,
that
so
home
tomorrow
inspection.
will be the exception.
Okay.
All right. Well, thanks,
Thank
Tracy,
you.
for being here. Toby, do you have any questions before we log out?
Oh, so
No,
that's
sorry,
it on
I
chapters
just-
1 and 2?
Yeah, that's it. I'm sorry, Toby, what did you say?
No, not at the moment. I had issues trying to log on for some
Oh, yeah, I
reason.
saw it. So the recording, I will upload that to the YouTube channel sometime this afternoon, early in the afternoon. And then you can go back and catch the parts that you missed. The parts that you missed are pretty straightforward definitions, though. Qualitative, quantitative, categories versus numbers. Discrete continuous, which was whole numbers versus decimal numbers. And I think you may have missed levels of measurement too, the nominal, ordinal, interval ratio part.
Yeah,
I do believe, though, in addition to what we talked about at the beginning, I think I made some videos on that are listed on the announcements page from near the beginning of the class too.
Okay, I'll go back and make sure
All right,
to
so
do that.
that's a good reminder for me. Maybe I'll resend out that link as well when I do that this afternoon.
Okay, that works.
All right. Well, it was good talking to both of you. And again, like if anything else pops up, just drop me a line and we'll get you taken care of. And then on to chapters 3 and 4 tomorrow.
Cool.
Sounds
Thank you
good.
so much. This is so awesome. This is working.
Yeah,
All right,
it's
so
very
far,
helpful.
so good. Let's not jinx it, but so far, so good.
Yeah.
Thank you very much.
Yeah, you bet. Good luck, guys. And I'll see you both tomorrow, I'm guessing. Okay?
Okay, yes.
Thank you.
Very good.
Thank
Good
you.
luck.
Thanks.